So far in this unit, we've talked about protons, neutrons, and electrons. And we've said that when the number of protons in an element changes, that is absolutely the number one thing that makes the element what it is. So if you change the proton, you change the element, okay? And then we also learned a little about neutrons, and that neutrons, the number of neutrons in the nucleus can also change. And that's when you have different isotopes of that element. Okay, and the one thing that we haven't discussed yet, which really is the biggest, is the most important one, is what about the electrons? Remember that picture at the beginning where the protons and the neutrons are all in the nucleus. Here's our nucleus here, and that's where all the protons and the neutrons are. And then outside the nucleus, sometimes I draw electrons like this with a little circle with a negative in them, and that represents the electrons. Is you've got all these electrons that are moving around in random positions in different ways, okay? And now what's interesting is the protons, obviously, those don't really change. Again, if you do, that's a type of nuclear reaction which we have discussed. The neutrons can change, but again, that's different isotopes. But the electrons can be lost and gained really, really easily. Another atom can come along and take one of these electrons, or another atom can come along and give and say, hey, you want another electron? I'll give you this electron. I've got it. And so electrons are getting shared, they're getting lost, they're getting gained all the time, okay? And so that's really, really common. Typically when a chemical reaction happens, back when we discussed nuclear reactions the other day, we'd said that it's usually the electrons that are involved in a chemical reaction. It's the nucleus that's involved in a nuclear reaction, but it's the electrons that are typically the ones that are moving around when a normal chemical reaction happens. Anyway, so when an atom gains or loses electrons, it forms what's called an ion. Okay, so an ion is not an isotope. An ion is an atom that has gained or lost one or more electrons. Okay, now let's think about this. Protons, let's write this down. Protons have a positive charge. Electrons have a negative charge. So if an atom loses one electron, it has lost a negative charge. Okay, so let's look at, for example, sodium. Normal sodium has 11 protons and 11 electrons. Okay, but if sodium loses an electron, now instead of having 11, now it only has 10. So now let's look all total here. There are 11 positive charges and only 10 negative charges, because remember, it lost an electron. Okay, another atom came along and took that electron from sodium. So with 11 positives and 10 negatives, if we put those two together, 11 positive, 10 negative, that equals positive 1. Okay, and so what that means is that when an ion has a positive charge, so it's positively charged, that means it has lost one or more electrons. Okay, and those are called cations. Okay, a cation, kind of like if you ever look at a battery has a positive end and a negative end. The positive end is called the cathode. And so a cation, like a cathode on a battery, is a positively charged ion. So for example, this hydrogen ion here is really just a hydrogen atom that lost one electron. Here, copper has lost 2 electrons, and here manganese has lost 5 electrons, which yes, can happen. Okay, so the opposite is also true. If you have a negatively charged ion, and again, I know in math, hey, but if it's minus, you subtract. I understand that. It's not math, it's chemistry. Okay, you have to think about it this way. Okay, nitrogen, for example, has 7 protons and 7 electrons. Many times, though, nitrogen, as you can see it right here, will gain 3 electrons. So instead of 7 electrons, many times nitrogen will actually have 10 electrons. So combine those together. Let's think about what that means. It means there's 7 positive charges. So there's 7 positives, and now there's 10 negative charges. Put those together, combine them together, what do you get overall? You get a -3 charge. Okay, so if an ion is negatively charged, it means it has gained, it has gotten more, it's gotten one or more electron. Okay, and those are called anions. Okay, so anions are negative, cations are positive. Again, like a battery has a cathode, the positive end, and it has an anode, which is the negative end. Okay, so Cl minus means chlorine has gained 1 electron has been gained. Nitrogen, as we already said, gained 3, and here sulfur would be gaining 2 electrons. Okay, so here's some more examples of ions. So here's iron with a +3 charge. That means it's lost 3 electrons. Here oxygen is a -2 charge, so it has gained 2 electrons. Sodium losing 1 with a positive charge, and fluorine gaining 1. Notice that when it's just 1, you don't write the number 1. You can just write a plus or a minus, and that means that that just means 1. If it's any number other than 1, like on iron over here or oxygen, you have to actually write the number. Okay, so here are some examples of this. I'm going to do a few of them for you, and then you can do the rest of them. Determine the number of protons, neutrons, and electrons in the following atoms or ions. Okay, why do I say atoms or ions? Because if it doesn't have a charge, then it's an atom. Okay, for example, letter F right here, that is a uranium atom. Okay, but if it has a charge, which means if there's something up in the corner there, any of these, it means that it's an ion. Okay, and we have to take that into account. So, for example, letter A is done for you. It's got 17 protons. Again, you have to use the periodic table. Chlorine has 17 protons, 18 neutrons, because 35 minus 17 is 18. And then with that minus charge, it means we've got 1 extra electron. So instead of 17 protons and 17 electrons, we have to add 1 more electron so that we have 18 negative charges and 17 positive charges. And together that equals -1. Positive 17 and negative 18 will add up to -1. Okay, let's do a couple more here. All right, so here is strontium. Strontium is number 38 on the periodic table. Has in this case, its average atomic mass is 87.6. So we'll round that up to 88 because that's what we do. So again, strontium number 38 on the periodic table. So that means it has 38 protons. 88 minus 38 is 50 neutrons. And with a +2 charge, that means it has lost 2 electrons. So it should have 36 if it were, or 38. If it were an atom, it would have 38 electrons, but it's lost 2, so that means it has 36 electrons. Okay, letter C, NB, has a mass of this one right here, and again, its average atomic mass is 92.91, but again, I give you the mass of 90. So its atomic number is 41. So that means it has to have 41 protons. And again, if I give you the mass, don't use the mass on the periodic table. Like on strontium here, I didn't give you the mass. So you have to use the mass from the periodic table. But here, remember, if that mass is up in the corner, that's the mass I want you to use. So 90 minus the 41 protons is 49 neutrons, and then with a +5, again, that means it has lost 5. So instead of 41 electrons when it was equal to the protons, it's 36 electrons. Okay, let's do a negatively charged one. Let's look at, for example, letter E, P3 minus. Phosphorus is number 15 on the periodic table, so that means it has 15 protons. And then neutrons, phosphorus has a mass of right around 31, so 31, and again, you got to get that from the periodic table. 31 minus 15 is 16 neutrons. And then with a -3 charge, that means we're going to add 3 electrons, so that's 18 electrons. Okay, and then the rest of them are ones that you should be able to do on your own. Example 2, let's just look at that here real quickly, and then we'll be done with today's lesson. Which of the following represents an atom? And really it shouldn't say atom, it should say atom. Well, atom's okay. Atom, and then we're going to add in here or ion. Okay, because remember, atoms are neutral. So if it's not an atom, then it has to be an ion. So which of the following represents an atom or ion with 34 protons? So first of all, what's the only element with 34 protons? It's selenium. So right away, that answer is out. It has to be selenium. Okay, then it has 46 neutrons, which means it has to have a mass. The protons plus the neutrons put together, 34 plus 46 is 80. So that means the mass has to be 80, which means this one is out because that has a mass of 46, and this one is also out. Okay, and then our last one is, it says it has 36 electrons, and 36 electrons means that there's 2 more negative charges. There's 36 negative charges. There's only 34 positive charges. Put those two together, what do you get? You get -2. That means it has to have a charge of -2. That one is out. It must be the one that has the -2 charge. And that is it for ions.